Next, we're going to start talking about multiplying binomials. To multiply binomials, we simply have to use the distributive property. We have to ensure that everything in the first binomial gets multiplied by everything in the second. So we're going to start out by taking 2x times 3x, which gives me a 6x squared. Then I'll take 2x times minus 7, which is a minus 14x. Next, I'll move to the positive 4. Positive 4 times 3x gives me plus 12x. And positive 4 times negative 7 gives me a minus 28. Now all I have to do is see that there are like terms here in the middle of that expression. So 6x squared, and combining my x terms, negative 14 plus 12 gives me a negative 2x. And then I have a minus 28 for my constant. Okay? So there is my product of 2x plus 4 times 3x minus 7, simply using distributive property. Example 2. Again, we want to make sure that each term in the first binomial gets multiplied with each term in the second binomial. So I'm starting out by taking n times n, which is n squared. N times negative 8 gives me a negative 8n. Then I got to remember to take the sign with the number, so negative 2 times n is negative 2n. And negative 2 times negative 8 gives me a positive 16. So when I combine my like terms, I have n squared minus 10n plus 16. So take a second and try the got it problem and see how you do. So we'll start by taking x times 4x, which is going to give me 4x squared. X times 3 gives me a positive 3x. Negative 6 times 4x is minus 24x. And negative 6 times 3 gives me a minus or a negative 18. So again, combining my like terms with the x's in the middle, 3 minus 24 gives me a minus 21x. And then my constant is a minus 18. And there is our product. Now another method that can be used is what we call a table method. And I don't use this one myself, but I'll throw it out there, and if you're comfortable with it and you want to try it, then that's something that you can use as well. So I'm going to take my product of x minus 4 and x minus 5, and I'm going to set them up in terms of a table. Okay? So I'm going to have x, and I'm going to have minus 5 across the top. And then I'm going to have x and the minus 4 down the side. So each binomial is represented. And now I'm going to look at the products that happen. Okay, in this square here I've got x times x, which gives me x squared. Here I've got minus 5 times x, which gives me minus 5x. I've got minus 4 and x intersecting here, so minus 4x. And minus 4 and minus 5 gives me a positive 20. So if I take those, I've got my x squared. Again, I can combine like terms here with the x's, gives me a minus 9x, and then the constant is a positive 20. If I go back to distributive property, I can see that I've got x squared minus 5x minus 4x and plus 20. I've got all the same terms that I had in the table. So it's just another representation that you can use to multiply these binomials. Okay? This would again simplify to x squared minus 9x plus 20. So I end up with the same thing in the end. Okay? The table just gives you maybe a little more of a visual representation. I myself prefer just using distributive property. Okay? So try this one using the table method. Okay? So we'd have a 4x and a minus 5. And then down the side we'd have an x and a minus 3. Okay? So the 4x and the x, where they intersect, would be a 4x squared. The negative 5 and the x would give me a negative 5x. Negative 3 and the 4x would give me a negative 12x. And the negative 3 and negative 5, when I multiply those, I get a positive 15. So I've got a 4x squared. Looking at my two like terms here on the diagonal with the negative 12 and the negative 5 is negative 17x and a positive 15. If I check that using distributive property, I still have my 4x squared. Here's my minus 5x. There's my minus 12x. and there's my plus 15, so that you can see we're coming out with the same terms and the same expression no matter which method we use. Okay? So take a minute and multiply these two together and see if you can do it using the table method. Alright, so I've got 3x and 1. I've got x and 4. So this would give me a 3x squared. X times 1 is x. 3x and 4 is 12x. And 1 and 4 is 4. So I'd get 3x squared. Combining my x's, I have a plus 13x. And my constant is a positive 4. And there is your solution. Now, another thing that gets used sometimes, or that you'll hear, is called FOIL. Okay? And the FOIL is simply an acronym. It's kind of a way to help you keep track, to make sure that everything in the first binomial is multiplied by everything in the second. And what the FOIL letters stand for are first, outer, inner, and last. And really, these are just the same things that would be used using distributive property. If I multiplied the first terms together, I'd multiply the 5x and the 2x, giving me 10x squared. If I multiply the outer terms, I'm multiplying the 5x with the 1. Those are the two outside terms if I look at the whole line of pieces there. So there's my plus 5x. The inner means I'm multiplying the two inside terms, so that's minus 6x. And last means I'm multiplying the last term in each binomial, which is minus 3. So you can see it's really exactly the same thing as distributive property. Some people just like to give fancy names and shortcuts to help remember the patterns that you're multiplying in, and that's nothing more than what the FOIL is. It's just to help you remember the pattern for multiplying two binomials together. So again, we'd have to combine our like terms here, and we end up with our expression. Okay? The thing to remember is that this FOIL only works if I'm multiplying two binomials. When I start multiplying a binomial and a trinomial, or two trinomials, then this idea of FOIL doesn't work anymore, because there's more than 4 terms when I'm multiplying other polynomials together. Okay? So this can help you with the binomial pattern, but just know that that's the only time that this works, is when you're multiplying two binomials together. Okay? So example 6, just another practice one here. Okay? So I'm going to take 3x, and I'm going to multiply 3x times x, and give me 3x squared. I've got 3x times 2, which gives me 6x. Negative 4 times x gives me minus 4x. Negative 4 times 2 is negative 8. So again, combining my like terms gives me 3x squared, leaves me with a positive 2x, and minus 8. Okay? So to finish out, I would like you to try these two got-it problems on your own. You can use distributive property, you can use the table. I don't care which method you use. I just want you to get comfortable with using one of those methods. Alright, so in part A, n times 4n gives me 4n squared. Then I'd have a minus 7n, minus 24n in the middle. Okay. Rewrite that one. And then I've got a negative times a negative gives me a positive 42. So combining like terms, I've got 4n squared minus 31n plus 42. In part B, I've got 2p squared times 2p. That's 4. P squared times p would be p to the third. 2p squared times negative 5 gives me negative 10p squared. 3 times 2p is a plus 6p, and 3 and negative 5 gives me a minus 15. And we notice here that we have no like terms to combine. So 4p to the third minus 10p squared plus 6p minus 15, that is our product. There are no like terms there that need to be combined. Okay? So hopefully you're getting the hang of this. We will work on some more of this in class tomorrow. We'll see you then.